In 6 days, 4 human beings will climb inside a capsule smaller than a minivan, sit on top of a rocket producing 8.8 million pounds of thrust, and leave the surface of this planet for the first time in 53 years, on a journey that will carry them further from Earth than any living person has ever been. Not to orbit, not to a space station 300 miles up where Earth fills every window and rescue is hours away, past the moon, into the deep, into the dark, into the place where the planet you were born on shrinks to a point of light indistinguishable from every other point of light in the sky. And when they look back, they will see something that no human being alive today has ever seen with their own eyes. They will see Earth the way Carl Sagan described it 50 years ago from a photograph. A pale blue dot, a mote of dust suspended in a sunbeam. A world so small it disappears, and in that moment, floating in a capsule the size of a family car, further from home than any human since the last Apollo astronaut stepped off the moon in December 1972, they will understand something that no amount of reading or watching or thinking can fully deliver. They will understand how alone we are, how far we have to go, how much we have already given up just to reach this distance, which is still nothing, which is still barely the first step on a staircase so long it has no visible top. Tonight we are going to follow those 4 astronauts into the dark. We are going to feel every mile of that journey from the moment the engines ignite to the moment they look back and see Earth disappear. And then we are going to keep going, past where they will turn around, past the moon, past the planets, past the edge of the solar system where Voyager 1 drifts in silence 15 billion miles from home. We're going to travel to the edge of everything we can see, and then we're going to stand there and ask the only question that has ever really mattered. What is out there, and why haven't we heard anything back? Before we begin, if this is the kind of journey you want to take with us, hit that like button right now and subscribe to the channel. Every single one of those actions tells the algorithm that this content matters, that slow, deep, honest science matters, and it means we can keep making these journeys together. Now, let us begin. The last time a human being went this far was December 14, 1972. His name was Eugene Cernan. He was a Navy pilot from Chicago who had grown up watching airplanes and dreaming of speed. He was 48 years old when he climbed into the lunar module Challenger on the surface of the moon, sealed the hatch behind him, and left. As he climbed the ladder for the last time, he paused. He looked around at the grey dust and the black sky and the blue earth hanging above the horizon, and he said words that nobody planned, words that just came out. He said, "We leave as we came, and God willing, as we shall return with peace and hope for all mankind." Then he climbed in, the hatch closed, the engine fired, and humanity left the moon, and did not come back. For 53 years, nobody came back. Think about what happened in those 53 years. The internet was invented. Personal computers went from filling a room to fitting in a pocket. The human genome was mapped. The Soviet Union collapsed. China became an economic superpower. 11 billion people were born and died. The entire digital age happened, and in all of that time, in all of those technological revolutions, not a single human being went back to the moon. Not a single human being went further from Earth than a few hundred miles. The International Space Station, our great outpost in space, orbits at an altitude of about 250 miles from the surface of the moon. That is so close, it is invisible. That is less than the distance from New York to Philadelphia. For 53 years, we have been circling our own planet like fish circling a fishbowl, pressing our faces against the glass, looking out at the universe we stopped reaching for. And now, on April 1st, 2026, that changes. 4 people are going. Their names are Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. Wiseman is the commander, a Navy veteran who has logged time in space before, who has trained for this mission for years, who understands every system in the Orion capsule well enough to fix it in the dark. Glover is the pilot, a Navy pilot himself, and the first person of color in history to travel beyond Earth orbit. Let that land for a moment. The first person of color to leave the protective shell of this planet and travel toward the moon. 53 years after the last human being did it, and we are finally doing it with the fullness of who we are as a species. Kosh is a mission specialist, and she will become the first woman in history to travel to the moon's vicinity. The first woman in all of human history. In all of the tens of thousands of years we have been looking up at that silver circle in the night sky, writing poems about it, navigating by it, praying to it, dreaming about it. Not one woman had ever gone there. Kosh will go there first. And Hansen, a Canadian astronaut, will become the first non-American to travel beyond Earth orbit. This crew is not incidental. This crew is a statement. It says we are not done. It says we are going back. And this time we are going back as the full version of humanity, not the partial draft that Apollo sent 50 years ago. Stop here for just a moment and tell us in the comments if you could choose one person from history to be on this crew, one person who never got the chance to see Earth from this distance. Who would you choose? The scientists, the dreamers, the explorers who spent their lives looking up but never got to go? Leave that in the comments. We want to read every single one. The rocket that will carry them is called the Space Launch System, the SLS. It is the most powerful rocket ever built, more powerful than the Saturn V that sent Apollo to the moon, which was itself the most powerful machine in human history at the time. The SLS produces 8.8 million pounds of thrust at liftoff. To help you feel that number, consider this. The thrust of a commercial airplane engine at takeoff is typically around 100,000 pounds. A single SLS core stage engine produces 512,000 pounds of thrust. There are 4 of them, plus 2 solid rocket boosters, each producing 3.6 million pounds of thrust on their own. At the moment of ignition, the SLS is consuming propellant so fast that if you poured the entire fuel load onto a football field, it would fill the field to the height of the goalposts in seconds. The sound alone is enough to cause physical damage. When SLS lights up at Launch Complex 39B at Kennedy Space Center, the sound waves will travel miles in every direction. Glass will rattle in windows 15 miles away. The ground will shake. The air itself will become momentarily visible as a shockwave of compressed sound rolls outward from the pad. And on top of this controlled explosion, inside a capsule called Orion, 4 human beings will be strapped into their seats, breathing through their helmets, watching their instruments, and waiting for the moment when gravity loses its grip. The first few seconds after ignition are the most dangerous, not because of the power, though the power is extraordinary, but because of the commitment. Once those solid rocket boosters ignite, there is no stopping. There is no abort that can save you from the full energy of that moment. The SLS does not have an off switch. It has a path, and that path leads up, straight up, through the atmosphere, through the clouds, through the blue thinning sky, through the point where the air stops and space begins. In just over 8 minutes, the SLS main engines will shut down and Artemis II will be in low Earth orbit, moving at 17,500 miles per hour, circling the planet once every 90 minutes. And the engines will be silent, and the crew will begin their work. But low Earth orbit is not where they are going. Low Earth orbit is the parking lot, the first stop, the place where they check the car before the real drive begins. For 23 hours, the crew will orbit Earth in the most demanding checkout of a spacecraft ever conducted with human lives depending on the results. They will test every system: life support, navigation, propulsion, communications, thermal control. They will test the spacecraft's ability to respond to commands. They will test the manual control systems, actually taking the wheel and flying Orion by hand, simulating the docking maneuvers that future missions will require. And they will do all of this close enough to Earth that if something goes wrong, if a critical system fails, there is still a possibility of rescue. There is still a lifeline, because once they fire the engine that sends them toward the moon, the lifeline disappears. Once they go translunar, they are on their own. The distance becomes too great, the response time becomes too long, and the only way home is forward. Think about what that means for a moment. Imagine you are Reed Wiseman. You are sitting in the commander's seat of a spacecraft in low Earth orbit. You can see Earth out of your window. It is close enough that you can make out the shapes of continents. You can see the curve of the atmosphere, that thin blue line that is the only thing standing between life and the void. And in a few hours you're going to fire an engine that will take you away from that. You will watch Earth get smaller. You will watch it go from a continent to a marble to a disk to a point. And there will be a moment, a specific moment that every Apollo astronaut described but none of them could fully prepare for, when you can cover the entire Earth with your thumb, when everything you have ever loved, everyone you have ever known, every city, every ocean, every mountain, every forest, every person you have met in your entire life fits behind your thumb now, and it will keep getting smaller. On flight day 2, the engine fires. The trans-lunar injection burn. It is about 5 minutes long. In those 5 minutes, Orion accelerates from its orbital speed of 17,500 miles per hour to a speed sufficient to escape Earth's gravitational grip and coast toward the Moon. The burn is clean, the trajectory is precise. Orion is now on a free return trajectory. This is the same type of path that Apollo 13 used in 1970 after an oxygen tank exploded and nearly killed the crew. A free return trajectory is shaped like a figure 8. Gravity does the work. Earth's gravity catches Orion as it departs. The Moon's gravity bends the path around the lunar far side. And then Earth's gravity catches it again on the way back, pulling the capsule home without requiring a single additional engine burn. It is one of the most elegant pieces of celestial mechanics in the history of spaceflight. A path through space maintained entirely by gravity. A path you can fall along for 10 days and end up exactly where you need to be. For the next 4 days after that burn, the crew will travel toward the Moon, and during those 4 days, something will happen to Earth that no words fully prepare you for. It will shrink, steadily, continuously, without stopping. On day 2, it is a marble. On day 3, it is a blue circle about the size of an aspirin held at arm's length. On day 4, it is smaller still. And on day 5, when Orion enters what NASA calls the lunar sphere of influence, when the Moon's gravity becomes stronger than Earth's and the spacecraft begins to fall toward the Moon instead of away from Earth, the crew will look back and see a planet they can blot out with one hand, a planet where 8 billion people are living their lives right now. Going to work, having arguments, eating breakfast, watching videos. 8 billion people, and from here, they are invisible. From here, the entire civilization of human beings is a blue smudge in the dark, and it is getting smaller every hour. Does that feeling unsettle you? Does the thought of looking back and seeing your entire world reduced to a point make something in your chest tighten? Leave it in the comments. Tell us what that image does to you, because we think it is one of the most important images the human mind can hold, and we want to know if you feel it too. On day 5, Orion reaches the Moon, and here is where the mission becomes something the Apollo program never did. Apollo orbited the Moon. Apollo 8 circled it 10 times. Apollo 11, 12, 14, 15, 16, 17 all went into lunar orbit and either landed or attempted to. Artemis II does not orbit the Moon. It flies around it on a free return arc that brings it within approximately 6,400 miles of the lunar surface on the near side and takes it approximately 5,000 miles beyond the Moon on the far side. And those 5,000 miles beyond the Moon are the furthest any human being will have traveled from Earth in 53 years. The furthest any living human has ever been, the furthest from home in the history of our species since Eugene Cernan closed that hatch in 1972. And when they are there, on the far side of the Moon, there will be something that the Apollo crews also experienced, but that people rarely talk about. There will be a moment of complete communications blackout. The Moon itself will be between them and Earth. Every radio wave, every signal, every voice, every piece of data will be blocked by 2,000 miles of solid rock. They will be completely alone, more alone than any human beings in history, not just far from home, actually cut off from it, unreachable. Listening to silence where the voices of Earth used to be, Apollo astronaut Michael Collins orbited the Moon alone while Armstrong and Aldrin were on the surface. He described the lunar far side blackout as the most profound silence he had ever experienced. Not frightening, he said, peaceful, complete, like being the only person in a very large, very quiet room. But Collins was 69 miles above the surface. The Artemis II crew will be 5,000 miles beyond the Moon, and the silence will be the same. The rock and the distance will make no difference to the radio waves. The Earth will be gone, And for those minutes, 4 human beings will be more alone than any human beings have ever been in the 4 million years of our existence as a species. Take a moment right now and just sit with that thought. 4 people, alone, further from Earth than anyone alive, and the silence of a universe that has not yet answered any of our calls. If you are listening to this tonight, if you are settling in and letting this wash over you, just breathe with that for a second. Because we think it is important. We think it is one of the most important facts about this mission, not the engineering, not the history, the aloneness, the fundamental human experience of being far from home in a universe that does not bend to accommodate our comfort. Now let us come back to the capsule, because when Orion swings around the far side of the moon and the Earth comes back into view on the other side, something remarkable happens. It rises. Earth rises over the lunar horizon, exactly the way it did in the famous Earthrise photograph taken by Apollo 8 astronaut William Anders in December 1968. A blue and white sphere rising above a grey, airless, ancient landscape. In 1968, that photograph changed something in the human consciousness. It was the first time we had seen our planet, as a whole object, isolated in space, beautiful and fragile and alone. Anders himself said that they went to explore the moon and what they discovered was the Earth. What the Artemis II crew will see is the same site, the same Earth, but 58 years later, 8 billion people instead of 4 billion. A planet that has changed enormously in those decades, some of it for better, some of it not. But the same blue marble, the same blue nubble, the same thin line of atmosphere, the same silence surrounding it. And they will photograph it, and they will send those photographs back to us, and we will see our planet from the moon again for the first time in 50 years. And maybe, if we are lucky, if we let it work on us the way the original Earthrise photograph worked on the generation that saw it, we will feel something shift. But then, Orion turns for home, and the return journey begins. 4 days back, Earth growing larger in the windows, the blue marble swelling back into a sphere you can no longer cover with your thumb. And then larger still, until the atmosphere is visible, until you can see clouds and oceans, until you can see the curve of coastlines. And then the capsule separates from the service module, the heat shield faces forward, and Orion hits the upper atmosphere at 25,000 miles per hour. The fastest re-entry of any crewed spacecraft in history. The heat shield will reach temperatures of around 5,000 degrees Fahrenheit. The plasma surrounding the capsule will create a communications blackout. For a few minutes, the crew will be surrounded by fire and silence simultaneously. And then the parachutes will open, and the ocean will rush up to meet them. And the Navy will be there waiting. And Reed Wiseman and Victor Glover and Christina Koch and Jeremy Hansen will climb out of that capsule and stand on the deck of a ship in the Pacific Ocean and breathe air that has been breathed by every human being who has ever lived, and the world will know that we left, and we came back, and we are not done. But here is the question that this mission is really asking. Here is the question underneath the engineering and the history and the firsts. Not where are we going next. That answer is known. Artemis III will test a lunar lander in Earth orbit. Artemis IV in 2028 will land on the moon. Those plans exist. The question is bigger than that. The question is, given how far we have traveled in these 10 days, given how small Earth looks from the vicinity of the moon, given how alone those 4 astronauts will feel on the far side when the radio goes silent, how far is it really to anywhere else? How far do we actually have to go before we find something other than silence? Because the moon is close, the moon is, cosmically speaking, next door, and it takes us 10 days to get there and feels like the edge of everything. So what does that say about everywhere else? Let us keep going. Let us follow the Artemis II crew's trajectory outward, past where they will turn around, past the moon, past the neighborhood, and see what is really out there, because the honest answer is more unsettling than almost anyone is prepared to hear. And it is important, not because it should discourage us, but because it should humble us. And humility, genuine cosmic humility, is the beginning of wisdom about what we are and where we are. The Moon is 238,805 miles from Earth. That is far by every human measure. It takes 10 days in a spacecraft. A commercial airplane flying at 600 miles per hour would take 16 days. A car driving continuously at 70 miles per hour would take 142 days. A person walking at 3 miles per hour, 24 hours a day without stopping, without sleeping, would take about 27 years. By every measure of distance that our bodies and our machines have historically used, the Moon is impossibly far. And yet in the scale of the solar system, the Moon is so close to Earth that on most diagrams of the solar system, the Moon's orbit cannot even be shown. The Moon and Earth appear as a single point. The next destination, if we ever go there with human beings, is Mars. And Mars is not close. At its nearest approach to Earth, when both planets are aligned on the same side of the Sun, Mars is about 33 million miles away. That is 140 times the distance to the Moon. The journey by spacecraft, using current propulsion technology, takes between 7 and 9 months, depending on the alignment of the planets. A signal sent from Earth at the speed of light, the fastest speed permitted by the laws of physics, takes between 3 and 22 minutes to reach Mars depending on where the two planets are in their orbits. That means that when mission controllers on Earth send a command to a rover on Mars, they wait up to 22 minutes just to hear that the command was received. A conversation is impossible. Real-time communication is impossible. The crew on a Mars mission will be alone in a way that makes the Artemis II crew's lunar far side blackout look like a brief interruption. They will be alone for months, with a communication delay measured in minutes, turning every exchange with home into a slow-motion letter across a gulf of space. And yet, Mars is right next door. Mars is practically touching us. In the scale of the solar system, Mars is the house across the street. The gas giants, Jupiter, Saturn, Uranus, Neptune, are the houses on the other side of town. Jupiter, the largest planet in our solar system, orbits the Sun at a distance of 484 million miles. Saturn, with its rings visible through even a modest backyard telescope, sits 886 million miles from the Sun, on average. Neptune, the outermost planet, orbits at 2.8 billion miles from the Sun. Voyager 2, the fastest thing we have ever launched toward Neptune, took 12 years to get there. 12 years of continuous travel at tens of thousands of miles per hour. And it arrived at Neptune in 1989 for a flyby lasting a matter of hours. We have never gone back. We have never sent another spacecraft to Neptune. Getting there once took everything we had. But even Neptune, even that lonely blue world at the edge of the planetary system, is not the edge of the solar system. Not even close. Beyond Neptune lies the Kuiper Belt, a vast region of icy bodies where Pluto orbits and where countless frozen objects circle the Sun in the cold and the dark. And beyond the Kuiper Belt lies the scattered disk. And beyond the scattered disk lies the Oort cloud. The Oort cloud is the outermost boundary of the Sun's gravitational influence. It is a vast spherical shell of perhaps hundreds of billions of icy bodies loosely bound to the Sun by gravity, beginning at roughly 2,000 times the Earth-Sun distance and extending outward to perhaps 100,000 times that distance. Voyager 1, the most distant human-made object in existence, has been traveling since 1977. It is currently about 155 times the Earth-Sun distance from home. It has been traveling for 49 years, and it has not yet reached the Oort cloud. It will not reach the inner edge of the Oort cloud for another 3 centuries. And it will not pass through the other side of the Oort cloud for roughly 30,000 years. 30,000 years, that is longer than all of recorded human history, longer than the time between the cave paintings at Lascaux and this moment. Voyager 1 will spend 30,000 years just crossing the outermost shell of our solar system, and at the end of those 30,000 years, it will not have come close to another star. The nearest star to our Sun is Proxima Centauri. It is 4.24 light-years away. 1 light-year is the distance light travels in 1 year. Light travels at 186,000 miles per second. In 1 year, light covers about 5.88 trillion miles. Proxima Centauri is 4.24 times that distance. At Voyager 1's current speed, reaching Proxima Centauri would take over 73,000 years. If Voyager 1 had launched at the dawn of human civilization, when the first cities were being built in Mesopotamia, when the first writing was being pressed into clay tablets in Sumer, it still would not be there yet. It would not arrive for another 60,000 years, and Proxima Centauri is the nearest star. The nearest star out of the 250 billion stars in the Milky Way, the nearest star out of an estimated 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars. Proxima Centauri is as close as stars get, and it is still so far that our fastest spacecraft, moving continuously since 1977, would need 73,000 years to reach it. If there is a planet around Proxima Centauri with someone on it who is wondering if they are alone in the universe, and if they sent a radio signal toward us right now, that signal would take 4.24 years to arrive. If we answered immediately, they would receive our reply 8.5 years from now. A single exchange of messages would take nearly a decade, and Proxima Centauri is the nearest possible neighbor. This is the context in which Artemis II is flying. This is the scale into which those 4 astronauts are departing. They are going 5,000 miles beyond the Moon. The Moon is 238,000 miles away. Proxima Centauri is 25 trillion miles away. The Artemis II crew is traveling less than 1/1,000,000% of the distance to the nearest star. And it will be the furthest any human has gone in 53 years. And it will feel immense, and it will feel dangerous, and it will feel like the edge of everything. Because for us, for human beings with our bodies and our lifespans and our technology, it is close to our edge. It is near the limit of what we can currently do, and the universe extends 4 million times farther than we can currently reach, and then another 4 million times beyond that, and then another, and eventually you arrive at a distance so large that the number has no meaning. Pause with us here. If you are watching this in bed or lying on the couch or settling in for the night, just look up for a moment. Look at wherever the ceiling is and understand that above that ceiling, above the roof, above the clouds, above the atmosphere, above the moon, that is rising tonight somewhere in the sky, above all of that, in a direction that is not up but is simply away from everything you know, the universe extends in a distance that cannot be felt, only calculated. And the Artemis II crew is going just far enough to feel a tiny corner of that, just far enough to see Earth disappear, just far enough to know in their bones what everyone who has ever looked at the night sky has known in their minds but has not felt in their blood. We are small, this place is vast, and it does not end. Let us talk about what happens out there in that vastness, because it is not nothing. People imagine space is empty, as peaceful, as silent, and in some ways it is. But the universe is not inert. The universe between stars, the interstellar medium, is not a vacuum. It is a thin but measurable environment, filled with galactic cosmic rays, high-energy particles from supernova explosions, from neutron stars, from black holes, from the most violent events in the galaxy. These particles travel at significant fractions of the speed of light. They come from every direction. They pass through everything. When Voyager 1 crossed the heliopause in 2012, the boundary where the sun's protective bubble ends and true interstellar space begins, its instruments registered a surge in galactic cosmic ray flux. The solar wind, which had accompanied the spacecraft for 35 years, vanished. The magnetic field shifted from solar to galactic, and the radiation environment became something that no human body could survive for long without extraordinary protection. The heliosphere is what protects every living thing on Earth from this environment. It is a vast bubble inflated by the solar wind, the sun's continuous outpouring of charged particles. The sun exhales constantly, and that exhalation creates a bubble around the entire solar system, pushing back the galactic cosmic rays, deflecting the interstellar radiation. Inside the heliosphere, the cosmic ray flux is reduced by roughly 70 to 75%, compared to interstellar space. That reduction is what makes complex life possible. Without it, DNA would be shredded by radiation far faster than cellular repair mechanisms could fix it. The evolution of complex life may depend on living inside a star's protective exhalation, and every single living thing on Earth has spent its entire existence inside this bubble, protected, without knowing it existed. Artemis II will stay well inside this bubble. The Moon is inside it, Mars is inside it. Even the outer planets are inside it. But the question that Artemis II's launch forces us to ask, the question that the scale of space forces us to confront, is what happens when we want to go further? What happens when we want to go to another star? What happens when we try to cross the ocean between stellar systems, the interstellar medium that Voyager measured, the radiation-soaked void that stretches light years in every direction between every star and its neighbors? Because that is the journey that the logic of exploration eventually demands. And the honest answer, the answer that the data supports, is that we are not ready, not even close to ready. And the universe may be designed in a way that makes it extraordinarily difficult to ever be ready. And this is where the story of Artemis II, the story of 4 people going further than any human has gone in 53 years, connects to the deepest question in all of science. The question that Fermi asked at lunch in 1950 at Los Alamos National Laboratory, while eating a sandwich and talking to colleagues about the probability of extraterrestrial life. If the universe is so large, if there are 2 trillion galaxies, if there are 10 to the 24th power stars, if even a tiny fraction of them have planets, if even a tiny fraction of those planets have conditions suitable for life, then where is everyone? Where are the signals? Where are the visitors? Where are the signs that we are not the only ones who learn to look up? The Milky Way is 100,000 light years across. At any speed less than light, crossing it would take tens of thousands to hundreds of thousands of years. But even at modest speeds, a civilization that started expanding 1 billion years ago could have colonized the entire galaxy many times over by now. The Sun is only 4.6 billion years old. The galaxy is 13 billion years old. There are stars in this galaxy that are 10 billion years old. 12 billion years old. If any of them have planets with civilizations even 1 billion years ahead of us in development, those civilizations could have had unimaginable technological capabilities for hundreds of millions of years. They could have sent signals, probes, self-replicating machines, any number of things, and yet we see nothing. We hear nothing. The sky is silent. There are many proposed answers to this silence. Some say life is vanishingly rare, that the emergence of life from chemistry is so improbable that we may be the only example. Some say civilizations invariably destroy themselves before becoming interstellar, that the same technology that allows a civilization to reach for the stars also gives it the tools for self-annihilation. Some say the answer is the dark forest, a concept explored by the science fiction writer Liu Cixin, which proposes that the universe is not silent because it is empty, but because every civilization that is listening has also learned to be afraid of what is listening back. In a universe where the resources are finite and the distances are vast and the intentions of others are unknowable, the safest strategy is silence. Reveal yourself and risk destruction. Stay quiet and survive. But there is another answer, a simpler one. One that Artemis II and the scale of the journey that those 4 astronauts are taking makes viscerally real. The answer may simply be distance. The universe may be full of life, full of civilizations, full of beings who look up at their night sky and wonder what is out there and feel the same loneliness and awe and terror that we feel. But the distances between them may simply be too large, not just technically difficult to cross, functionally, practically, cosmically impossible to cross in any timescale meaningful to a biological civilization. The Milky Way is an archipelago of 250 billion island stars separated by oceans of light years. To swim from one island to another with the technology we have would take thousands of generations, and each generation would have to maintain the mission, maintain the culture, maintain the purpose, across the emptiness, in ships that are the total environment for everyone alive, for centuries, for millennia, even if it were possible. Even if the radiation could be shielded, and the food grown and the oxygen recycled and the people kept sane in the dark, the time required would outlast any civilization as we understand civilization. Because civilizations change, purposes drift, technologies develop in unexpected directions. A ship launched toward a star with one goal in mind might arrive 10,000 years later with a population that has entirely forgotten what the goal was or has decided something else matters more. And that is the most haunting possibility of all, that we are not alone, that the universe hums with life, with mind, with awareness, with the same desperate hunger to connect that we feel when we look at the stars, but that we are separated from all of it by distances that dwarf our lifespans the way our lifespans dwarf the lifespan of a mayfly, that every civilization is an island, that the ocean between the islands is not merely wide but is measured in units so large they become philosophical rather than physical, and that the radio signals, the messages in bottles that every civilization presumably sends into the dark, are spreading outward at the speed of light through a universe that is expanding faster than light in its furthest reaches, diluting, weakening, fading, probably never heard by anyone. Our own radio bubble is 125 light years in radius. It has been expanding since the early 20th century when we began leaking radio waves into space. That bubble contains a few thousand stars. The Milky Way contains 250 billion. Our radio presence is a grain of sand on a beach. We have been shouting into the void for a century, and the void has not noticed, not because there is no one there to hear, perhaps because the void is simply too large for our shout to carry. And yet here we are on April 1st, 2026, watching 4 people leave the surface of this planet on the most powerful rocket ever built, heading toward the moon, heading 5,000 miles beyond it, further than any human has gone in half a century, and we are not paralyzed by the scale. We are going anyway, because that is what we do. We go anyway. We always have. We left the caves not knowing what was over the next hill. We sailed off the edge of the known ocean, not knowing if there was another shore. We climbed into tin cans on top of controlled explosions and told each other it was fine, it was doable, we had done the math, and then we did it anyway and came back alive and went again. We go anyway. It is perhaps the single most defining characteristic of this species. Not intelligence, not language, not art or mathematics or empathy, though we have all of those. The defining characteristic is that we go anyway. We go even when the scale of what we are attempting is so much larger than us that it should be laughable. We go anyway. But there is something different about Artemis II that was not present in the same way in the Apollo program. Apollo was a race. It was driven by the existential competition of the Cold War, by the terror that the Soviet Union might plant a flag on the moon first, and what that would mean for the ideological balance of power. Apollo was magnificent. Apollo was an achievement so astonishing that it still does not feel real 50 years later. That footage of Neil Armstrong stepping off the ladder still makes something in the chest tighten. But it was a race. And when America won the race, the funding dried up. The momentum stopped. The program ended. Cernan was the last man on the moon, not because there was nothing more to do there, but because the race was over and there was nothing left to prove and the money went elsewhere. Artemis is different. Artemis is not a race in the same sense, though there is a Chinese lunar program that provides urgency. Artemis is a program, a sustained, architectured long-game program designed not to win a single victory and stop, but to establish a permanent human presence in deep space. Not just visit the moon again, but build a gateway station in lunar orbit. Not just send a crew to the moon, but actually stay, do science, learn the terrain, use it as a stepping stone. And beyond the moon, eventually Mars, a journey that will require everything we know and more that we have not yet learned, to survive the radiation of interplanetary space for 7 months each way, to land on a world with 1/3 Earth gravity and a carbon dioxide atmosphere and dust storms that last for months, to grow food there, to build something there, to start a second chapter of the human story in a different place. Artemis II is the first sentence of that chapter. It is 4 people in a capsule going further than any human in 53 years. It is small by the scale of what the program intends. It is enormous by the scale of what human beings have been doing since 1972, and it is happening right now, in the days you are living in the same week you are listening to this, in a moment of history that you will be able to tell people you witnessed. There are very few moments like that in a lifetime. The moon landing happened once. The first images from Hubble happened once. The first gravitational wave detection happened once. The confirmation of the Higgs boson happened once. These are the moments when humanity does something it has never done before, and the shape of what is possible changes. Artemis II is one of those moments. Here is something we want you to think about tonight, lying here in the dark while this washes over you. If you were on that spacecraft, if you were in Wiseman's seat, or Glover's seat, or Koch's seat, or Hansen's seat, and you were 5,000 miles beyond the moon, and Earth was a blue point of light behind you, and the sun was a bright star ahead of you, and everything else was black, what would you feel? Not what do you think you would feel. What do you actually believe you would feel in that moment? The research on astronaut psychology suggests that the most common response is something called the overview effect. A sudden, profound, unshakable sense of the fragility and preciousness of Earth. A sense that Borders described it as erasing all the artificial lines we draw on it, the borders and the flags and the fences, the things we fight over, and revealing the actual object underneath, a small wet rock in a very large dark place, keeping everything alive by a hair. A sense of responsibility that is reported as physically overwhelming. Many astronauts have described coming back from space changed in ways that are difficult to communicate to people who have not experienced it. Not religious exactly, but close to that, a reorientation of what matters, a silencing of the noise, a clarity. We will never experience it the way those four people will, but we can approximate it. We can let the scale work on us. We can allow the numbers to be felt rather than just understood. 238,000 miles to the moon, 5,000 miles beyond it, 25 trillion miles to the nearest star, 2 trillion galaxies in the observable universe, 10 to the 24th power stars, 93 billion light-years across, and us here on a planet with blue oceans and an oxygen atmosphere, and billions of people who mostly do not think about any of this on any given Tuesday. We are improbable. We are astonishing. We are, by any cosmic measure, the most complex and unlikely arrangement of matter that has ever occurred in the observable history of this universe. And we know it, and we are going anyway. And Artemis II is the latest and most recent expression of that going, and it is happening in 6 days. Before we go further, if this kind of journey is what you come to this channel for, subscribe right now and ring the bell. Not for us, though it helps enormously, but because you deserve to be notified when the next journey begins. Because there are more of these coming, because the universe is not going to run out of questions, and we are not going to run out of ways to sit with them in the dark together. Let us now go somewhere that Artemis II will not go. Let us go past the moon, past Mars, past the outer planets, past the heliopause where Voyager crossed into interstellar space. Let us go all the way to the edge of the observable universe and stand there for a moment and look back. Because the Artemis II mission makes more sense, matters more, means more, when you see it against the full backdrop of where we are trying to go. The observable universe is a sphere centered on Earth with a diameter of approximately 93 billion light-years. That number requires some explanation because it seems impossible. The universe is 13.8 billion years old. So how can we see 46 billion light-years in any direction if light has only had 13.8 billion years to travel? The answer is expansion. When a distant galaxy emitted light 13 billion years ago, that galaxy was much closer to us than it is now. The light began its journey. But while the light was traveling, space itself was stretching. The galaxy was being carried farther away by the expansion of the universe. By the time the light finally reaches our telescopes, the galaxy that emitted it is now 46 billion light-years away. The universe has been expanding the entire time the light was in transit, so what we can see is not limited by the speed of light alone. It is shaped by the expansion of space, and that expansion has been going on for 13.8 billion years, stretching the visible universe to a sphere 93 billion light-years across. Inside that sphere, there are an estimated 2 trillion galaxies. 2 trillion, each one containing hundreds of billions of stars. The total number of stars in the observable universe is estimated at 10 to the power of 24. That is a 1 followed by 24 zeros, more stars than all the grains of sand on every beach and desert on Earth. And around most of those stars, there are planets. and some unknown fraction of those planets orbit in the zone where liquid water can exist on the surface. And some unknown fraction of those planets have oceans and atmospheres and chemistry complex enough to produce life. And some unknown fraction of those produce life that persists long enough to evolve complexity. And some unknown fraction of those develop intelligence. And some unknown fraction of those develop technology. The fraction at each step could be enormous, or it could be vanishingly small. We have one data point. We are it. And from that one data point, we cannot tell whether the universe is teeming with life or whether we are alone. Both are possible. Both are consistent with everything we know. But here is something that Artemis II has highlighted, that the 10 days of that journey and the experience of those 4 astronauts will highlight, that the distance and the silence and the smallness of Earth from the vicinity of the Moon highlights. The universe does not care about our desire for company. The universe was not designed to make it easy for intelligent beings to find each other. The distances are not convenient. The speed of light is not generous. The laws of physics do not bend for loneliness. If there are other civilizations out there in the 2 trillion galaxies, they are separated from us by distances that are not merely large, but are structured specifically to prevent contact on any timescale relevant to human life. A signal sent from a civilization in the Andromeda galaxy, the nearest large galaxy to the Milky Way at 2.5 million light-years, would take 2.5 million years to reach us. Their civilization would be unrecognizable to them by the time we replied. The civilization that sent the signal and the civilization that received the reply would have nothing in common, would not be the same people in any meaningful sense. This is the architecture of the universe, and it is either a tragedy or a liberation depending on how you look at it. A tragedy because the universe may be full of minds and all of them may be permanently isolated from each other by distances that cannot be crossed. A liberation because it means we are not late to a party we were not invited to. It means every species that looks up from its own planet is looking up at the same scale problem we are looking at, is feeling the same vertigo we are feeling, is sending its own equivalent of Artemis II into its own equivalent of the dark, a few thousand miles further than anyone has gone before, with 4 of its kind in a small capsule, wondering what is out there and going anyway. Think about that for a moment. Think about every civilization in the universe that has ever developed the capacity to leave its planet. Every species that grew from chemistry to biology to intelligence to technology, that eventually built its equivalent of the Space Launch System and strapped its equivalent of Reed Wiseman and Victor Glover and Christina Koch and Jeremy Hansen into a capsule and aimed them at the nearest moon or the nearest planet, and felt on that day exactly what we are feeling now. The mixture of pride and terror, the mixture of achievement and humility, the mixture of going further than we have ever gone and knowing, simultaneously, that further is barely the beginning. Every one of those civilizations, if they exist, experience this moment, this precise mixture, this launch day, this pale blue dot growing small in the window. We are not alone in that feeling, even if we are alone in the universe. The feeling itself is universal. The physics that produces it is the same everywhere. And that thought, of all the thoughts in this journey, is the one that does something unusual to the chest, something that is neither sadness nor joy, but is made of both. Now let us come back to Earth. Let us come back to the present moment, because there is something happening right now, today in the weeks before the launch, that is worth noticing. The crew of Artemis II is in quarantine. They have been isolated from the public, from large gatherings, from unnecessary exposure. For the weeks before launch, they are being protected. The way you protect something precious. The way you protect something that you are about to send somewhere it has never been. They are eating the food that NASA has carefully selected for them. They are sleeping on schedules designed to align their circadian rhythms with the mission. They are exercising in specific ways to maintain the muscle mass and bone density they will need in microgravity. They are meeting with engineers and mission controllers and psychologists and every kind of expert you can imagine, going over every scenario, every contingency, every what if. They are doing all of this because the universe does not forgive unpreparedness. Because 4 human lives are depending on every decision that has been made for years leading up to this moment, and because the mission they are about to fly matters. not just to NASA, not just to America, to the idea of what we are as a species and where we intend to go. And when they launch, whenever launch day comes, whether it is April 1 or April 2 or sometime later in April, whenever the engines ignite and the rocket clears the tower and climbs into the Florida sky, something important will happen. Not just a spacecraft will leave Earth. Something in the human story will turn. A page will turn. The chapter that began with a quiet ending in December 1972, when Chernin climbed that ladder, will close, and a new one will open. One that is supposed to not stop this time. One that is supposed to keep going through Artemis III and Artemis IV and the Gateway Station, and eventually to Mars, where the distances are so much larger and the isolation is so much deeper and the challenge is so much greater that we cannot fully imagine it yet. But we will get there, if we are what we have always been. If we are the species that goes anyway, we will get there. And every person who watches the Artemis II launch, every person who stays up to track the mission in real time on NASA's website, every person who stays up to watch Orion return and splash down in the Pacific, every person who feels something shift in their chest when they see those 4 people climb out of that capsule, is part of this, is part of the going, is part of the long, improbable, magnificent, terrifying project of a small species on a small planet trying to understand a universe that is almost incomprehensibly large and almost perfectly silent. Going anyway, always going anyway, because that is what we do. The universe spent 13.8 billion years building something that could look at it and wonder what it is. You are that thing. 4 people in a capsule the size of a minivan are that thing. Every astronomer who has ever pointed a telescope at the dark, every physicist who has ever written equations on a chalkboard at 2 in the morning, every child who has ever looked up at the moon and wondered what it is like up there, every human being who has ever felt the specific mixture of smallness and hunger that the night sky produces, is that thing. We are the part of the universe that looks back. We are the part that asks. We are the part that goes. And in 6 days, we are going again. What will you feel when you watch the launch? Tell us in the comments. Tell us what this mission means to you. Tell us whether you feel hope or fear or awe or grief for all the time we waited. Tell us what Carl Sagan would have felt. Tell us what your grandmother would have felt. Tell us what you would say to those 4 astronauts right now if you had 1 minute and they could hear you. Because we read every comment, and this community, these conversations in the dark, after the lights go out and the questions get large, is the best part of what we do here. And if you have been listening to this and you are not yet part of this community, subscribe now. Stay. The next journey is already being planned. And one last thing before we close tonight, something quiet to take with you into sleep. In 1990, Carl Sagan persuaded NASA to turn the Voyager 1 camera around one last time before switching it off forever. Voyager was about 6 billion miles from Earth. NASA turned the camera, and in the resulting photograph, Earth appears as a tiny point of light less than a pixel wide, caught in a scattered ray of sunlight barely visible against the darkness. Sagan wrote about that photograph in words that have outlasted almost everything else written about space in the 20th century. He said, "Look again at that dot. That is here. That is home. That is us." He went on to describe every human being who has ever lived, every king and every peasant, every young couple in love, every mother and father, every inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. Voyager took that photograph from 6 billion miles away, a distance so trivial in cosmic terms that it does not register. And already, from that distance, Earth was invisible to the naked eye. Now imagine what Earth looks like from Proxima Centauri, 25 trillion miles away. Not a pixel, not a point, not even a detectable signal without instruments of extraordinary sensitivity. Not there at all, not real, not visible. Gone. And yet we are here, and we know it, and we are going anyway. Into the dark, with 4 people in a capsule, 5,000 miles past the moon, further than any human in 53 years, one more step in the longest journey any living thing has ever attempted. Good night. Safe travels to Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. Safe travels to all of us who are going with them in the only way we can, by watching, by wondering, by remembering that we are small and going anyway. If this journey moves something in you tonight, leave a comment telling us what you felt. Share this with someone who needs to be reminded that we are still going. And if you want to continue this journey with us, subscribe, and we will see you on the next one.